For many years, one of my main hobbies has been collecting and restoring antique radios. My latest acquisition is an old National NC-125. This is a general coverage shortwave receiver. It was made in the early 1950s. It has continuous frequency coverage from 550 kilocycles to 35 megacycles. A tuned RF amplifier stage, which can be adjusted, and two IF stages give this receiver excellent sensitivity and selectivity. The selector jet circuitry, proprietary to National, helps with the selectivity, rejecting unwanted interference. This is a picture of the radio as I received it after buying it off eBay. I did not even plug it in and turn it on after it arrived. That is never a good idea. If any of the old condensers in the set are bad, turning it on can cause damage which would be expensive to repair. While I waited for it to arrive, I had ordered a complete set of replacement condensers from Hayseed Hamfest. That is a great site where they actually make custom replacement can type multi-section condensers with equal capacitance and higher voltage ratings than the originals, and which replace the original type perfectly. The sets for each model of radio also contain all the other electrolytic condensers, as well as replacements for all the old paper and wax condensers in the radio. These paper and wax condensers are the ones which most often go bad. The ceramic disc types can drift out of spec, but almost never fail so as to cause any damage. Mica type condensers almost never fail or have to be replaced. In this next picture, you see the underside of the chassis complete, just as it was when I received it. To my great pleasure, I found that the radio had all original parts. It was entirely unmolested. Nobody had gone in and messed up things, so the restoration would be very straightforward. In this next picture, you see the first thing I replaced. I removed the old dual section 40 microfarad 450 volt electrolytic can and replaced it with the one from the set from Hayseed. It is the part in the center of the picture. The red circle is the base of the condenser with two terminals, one for each of the 40 microfarad sections. The replacement fit perfectly, and replacing the old one went very smoothly. Next we see where I've replaced another single electrolytic condenser, which is on the right side of the picture, and have started to replace the paper type condensers with modern, yellow, poly condensers of much higher voltage rating. These are more durable, handle greater voltage, and hold to their original value much better over time. Here we see even more of the condensers replaced. This next picture shows the chassis underside with all of the condensers replaced. There were two condensers which were a bit tricky to replace. This one is in the CWO circuitry, lurking beneath the other parts. The other one is at the back of the chassis, lurking beneath a potentiometer there. This one was one of the trickiest of the condensers to replace. Sometimes you just need the hands of a surgeon when you're into this hobby. In this next picture, I have begun to replace resistors which were no longer within tolerance or were almost out. I have found that this is a common problem on these old National receivers. They used almost all old carbon composition resistors, and over the years these have not lasted that well. It may be a result of their supplier, since on other sets of similar age from other manufacturers, I don't see as many resistors drifting as badly. This is something to watch out for if you ever work on old National equipment. In the next picture, we see the chassis work done. All the resistors which needed replacing have been replaced. All the electrolytic and paper condensers have been replaced. The old line cord, which was not cracked yet but was becoming brittle with age and would fail in a few more years, has also been replaced. That concluded all the actual chassis work. I must say, working on this radio was a pleasure. There was plenty of space under the chassis so that one could do the work pretty easily, except for the two instances I noted. and those were not that bad. I have dealt with a lot worse on old Philco receivers. Once all these parts were replaced, I tested all the tubes in the receiver. They were all good except for the 6V6 GT audio output amplifier. This is an 11-tube set with a 6SG7 RF amp, a 6SB7Y high-frequency mixer oscillator, a 6SG7 first IF amp, 6SG7 second IF amp, 6H6 second detector AVC ANL, a 6SL7 phase shifter, a 6SL7 GT boost reject audio amplifier, a 6SL7 first audio amplifier NCWO, a 6SV6 GT audio output amp, a 0A2 voltage regulator, and a 5Y3 GT rectifier. I could not test the 0A2 properly with my tube tester, so I measured its regulation live inside the set, and it measured 150 volts, exactly as it should. Next came the alignment, and that proved to be the most difficult part of this restoration. To begin with, I checked the intermediate frequency alignment and found that the frequency was way off. It seemed that somebody had decided to play with the adjustment screws on the top of the 3IF transformers. Here is a view looking at the top of the chassis as received. You can clearly see the 3IF transformers in the middle of the chassis with the adjustment screws on the top of each. I fed a modulated 455 kilocycle signal into the control grid of the pentagrid converter and peaked the 3IF transformers. Each transformer has two tunable cores, one for the input and one for the output. It took several passes back and forth to get them all peaked properly to 455 kilocycles, but it went quite smoothly. I wish the same could be said for the rest of the alignment. The only copy of the owner's manual I could find online was the one from Bama. It is not a very high-resolution scan, and the illustrations are not very clear, and the component values on the schematic are hard to read also. The problem with the illustrations makes it difficult to determine exactly where some of the coils and trimmer condensers are, which one must adjust to do the alignment. The manual also does not explain what each of these adjustments does exactly, so it took some time to figure all these things out. It took hours and hours to get the alignment just right, and a couple of trips from my workbench to the table where the leads from my outside antenna and ground are, then back again, before I had all the bands tuned in perfectly. Finally, though, all the bands were aligned. The frequencies which are shown on the dial match what is being received exactly, and everything is peaked up to be optimal on its reception. So, on to a demonstration for this receiver.